Hi, today we're looking at Functional Skills Maths Level 2. We've got the Training Qualifications UK exam board. This is past paper 13 and we're going to start with the non-calculator section. Question 1. Work out 0.982 minus 0.876. So let's write it out. Do it as a column, so we line up our units, our tenths, our hundredths, and our thousandths. And we start from the far right. So we want 2 minus 6. Well, we can't take 6 away from 2. So we're going to have to take 1 from the left. So we'll reduce the 8 by 1, take that down to 7. And we can give 1 across. So we've now got 12 minus 6, which is 6. 7 minus 7, which is 0. 9 minus 8, which is 1. Decimal point, 0 minus 0 is 0. So we get an answer of 0.106. Question 2. Round 9.9878 to 1 decimal place. So the 1 decimal place would be the 9 here. So we look at the digit after it. If it's 5 or more, we round up. And it is 5 or more because it's 8. So we need to increase the 9 by 1. Well, if we increase 9 by 1, it becomes 10. So that means that needs to become a 0. And we add 1 onto the previous number. So the 9 becomes a 10. So we actually have 10.0. And because it's to 1 decimal place, we need to have 1 digit after the decimal point. In this case, it just happens to be 0. Question 3. Work out 7 times 0.987. So I'm going to ignore the 0 point first of all. We'll just have our 987 times 7. 7 times 7. So we've got 7, 14, 21, 28, 35, 42, 49. So put the 9 and we'll carry the 4. Now we want 8 times 7. Well, if you remember, 7 sevens were 49. That was 7. So 8 sevens would be 56. Add on the 4. 57, 58, 59, 60. So put the 0 and we carry the 6. Now we want 9 sevens. Well, 8 sevens were 56. 9 sevens are 63. Add on the 6. Gives us 69. So we've got 6909. Now we need to put the decimal point in. And we had 1, 2, 3 decimal places. So we need to put the decimal point in 1, 2, 3 times there. So we end up with 6.909. Question 4. Write 72.5% as a decimal. 72.5. Well, if we're doing it as a decimal, we're dividing by 100. And if we're dividing by 100, we're going to make it smaller. With 2 zeros, that means we're going to move the decimal point once, twice. So we end up with 0.725. Question 5. This is for 2 marks. A carpenter is cutting wood in the shape of an isosceles triangle. We've got one angle here is 65 degrees, and these angles are both marked as x. The carpenter thinks angle x is 50 degrees. Is the carpenter correct? Okay, so if it's an isosceles triangle, what that means is 2 of the angles are the same, which is why we've got an x for both of them. What we do know is that the total angles in a triangle add up to 180 degrees. So if we add these all together, we'll find out if they add up to 180, then he's correct. If not, then he's wrong. So he's saying this is 50 degrees and this is 50 degrees. So in that case, we have 65, 50, and 50. So let's add those all together. 5 plus 2 zeros is still 5. 6, well, let's add the 5s together first. 5 plus 5 is 10, plus 6 is 16. So 165 degrees, well, that is not equal to 180 degrees. So is the carpenter correct? No. That's probably the most straightforward way of doing it. You can do other methods as well. I'll just put no in here. Question 6. Put these fractions in order, starting with the lowest. Okay, so if we look at these, one way is to get the denominators the same for all of them, but we might have to go a little while before we can find the lowest common multiple. Instead, I'm going to sort of do different things for each fraction. This one's already over 100, 33 out of 100, or 33%. Okay, so I'm looking at this one. This is out of 10. If I want to make it out of 100, I just need to multiply by the top and bottom by 10, or add a 0. Okay, so we can now see this is 30 out of 100, 33 out of 100. So this one is going to be smaller than this one. 1/4, well, 1/4 is also 25%, which means we can write it as 25 out of 100. So now we've got 3 out of 100, and we can use the numerators to see which is smallest, which is largest. This one here, what we can do is, well, this is 11, and I know 11 goes into 33 3 times. So I'm going to multiply the top and bottom by 3. 3 times 11 is 33, and 3 times 30, well, 3 times 3 is 9, and then put the 0 on. So we've got 33 over 90, 33 over 100. Well, this is 33 bits out of something smaller than this one, so this is going to be bigger. And because this one, 33, is larger than 30 and 25, if it's the biggest out of these three, then 33 over 90 must be bigger than all of them. I hope that makes sense. So let me write them out here. So we're saying the smallest one is the quarter. And I'm just going to put it in brackets, so that's 25 out of 100. Then we're saying the next one is this one, 3/10, which we worked out was 30 over 100. Then we're saying this one comes next, 33 over 100, so hopefully we can see they're getting bigger. And say this last one, 11 over 30, it's because we've said, well, that's 33 out of 90. We know this is bigger than this one, so it must be bigger than all the others as well. Question 7. A teacher asked 155 students at a college if they had a pet. The teacher recorded the information in this table. So in Class A, 56 students had a pet and 20 didn't. And in Class B, 64 had a pet and 15 didn't. What is the probability that a student chosen at random is in Class B and has no pet? Give your answer as a fraction in its simplest form. Well, we know there's 155 students in total, so that's going to go at the bottom of our fraction. We want the probability the student's in Class B and has no pet. Well, Class B is going to be this bottom row, and has no pet is going to be the second column. So we're looking at where they overlap, which is here. So it's going to be 15 out of 155. But they want the fraction in its simplest form, so we want to look for common factors, numbers that go into both 15 and 155. Well, because they both end in 5, I know we can divide them both by 5. So 15 divided by 5, well, 5, 10, 15, I know that goes 3 times. Let's divide 155 by 5. Well, we already saw, well, 5 doesn't go into 1, so we look at 5, how many 5s go into 15? We already saw that was 3. And then 5 into 5 goes once. So the bottom reduces down to 31. So we end up with a fraction of 3 over 31, or 3/31. Question 8. Alex drove down a 10-mile long road. It took Alex 0.25 hours to drive down the road. Alex thinks the average speed was 50 miles per hour. Is Alex correct? Show how you decide. Okay, so 10-mile long road. It took him a quarter of an hour. 0.25. So quarter of an hour. He thinks his average speed was 50 miles per hour. Well, if it's a quarter of an hour, if he carried on driving at the same speed for a full hour, it would be 4 lots of those. So it would be 4 lots of 10 miles. Well, 4 times 1 is 4, add on the 0. So we get an average speed of 40 miles per hour, which is not equal to 50 miles per hour. So we can say no. What you could do instead is you could divide the 50 by 4, so get a quarter of 50. But I think it's easier to say, well, if he does 10 miles in a quarter of an hour, he would do 40 miles in an hour, which means his average speed is 40 miles an hour, not 50 miles an hour. And on to question 9, which is worth 3 marks. Ty has a list of household chores to complete. The table shows how long it takes Ty to complete each chore. Dusting, 40 minutes. Vacuuming, 30 minutes. Tidying, 90 minutes. Ty thinks it takes... excuse me. Ty thinks it takes 1/4 of the total time to complete the vacuuming. Has Ty worked out the correct fraction? Well, let's work out the total time first of all. So add all of these. 0 plus 0 plus 0 is 0. 4 plus 3 is 7. Plus 9 is 16. Well, let's work out what a quarter of 16 is. And we can do that by saying 160. So not 16, 160 divided by 4. 4 can't go into 1, so we say 4 into 16. 4, 8, 12, 16 is 4 times. And 4 goes into 0, 0 times. So a quarter of the total time is 40 minutes, but he actually spends 30 minutes vacuuming. 40 is not equal to 30, so has Ty worked out the correct fraction? No, they haven't. And that's the end of the non-calculator section. So now we're on to the calculator section. Question 1. Draw a cuboid on this grid. Okay, so as you know, a cuboid is a 3-dimensional shape. It's generally made up of rectangles. It could have a square as well. I'm going to draw a quick sketch of a cuboid before I try and draw it more accurately. So for me, a cuboid is something like this. Some sort of box. Think of like a Amazon delivery box you might get. We just need to draw it on here now. Doesn't matter what size it is, but I would use your ruler. So we're going to draw this face first, the rectangle. And we'll draw it this size. Okay, now I would just like to think, well, we're going to have sort of diagonal lines here. Again, the size doesn't matter too much, so long as it's consistent. So if we think we're going to have this corner here, so we're going across 2 and up 2. So we do the same from this corner, across 2 and up 2. And then join those down here. And the same for this point, across 2 and up 2. There's our cuboid. Some people might like to do it so that you can sort of see a dotted line and see the lines in the background, almost like it's a see-through shape, but it doesn't matter. Either one of those would be fine. And that's for 1 mark. Question 2. Calculate 800 plus 600 times 2, all divided by 20 squared. Show you're working. Now, of course, we can use our calculator for this, but we just got to remember what order we need to do everything in. One thing to note is when you've got something written like this, almost as a fraction or as division, there are invisible brackets around the top and the bottom. Okay, so we're going to work out the top first, or, well, it doesn't matter, we work out the top, we're going to work out the bottom, and then we're going to do it as a division. Okay, normally we would use our BIDMAS rules. We say brackets first, then indices, then division, then multiplication, addition and subtraction come together. But as I say, because we're going to work out the top and bottom separately, it doesn't matter which order we work the two out. So let's go with the top. So that means we've got 800 plus 600 times 2. Now we do have to do the multiplication bit first. So that means we leave the 800 there, but we're going to need to do our 600 times 2, which gives us 1,200. Now we can add on the 800 to give us 2,000. That's the top. Now for the bottom, 20 squared, well, that means 20 times itself. So 20 times 20 gives us 400. So that means that all of this is the top, which is a 2,000, divided by the bottom, which is the 400. Now you could cancel some zeros like this and end up with 20 divided by 4, which I know is going to be 5. But if you want, we can check that on the calculator, which does give me 5. And we can write that in our answer box here. Question 3. Eden wants to put £4,600 in a new savings account for 2 years. The bank offers 3% compound interest per year. Eden thinks the account will have more than £5,000 at the end of the 2 years. Is Eden correct? Now, I like to put my commas in here to make it easy to read the numbers. So we've got a compound interest question. So we've got to think, we're starting with £4,600. It's in a savings account for 2 years with 3% interest. So the way we can do our 3% is by multiplying it by 1.03. If you think that it's 100% plus 3%, which makes 103%, and then the way we would turn that into a decimal would be 103 divided by 100 to give us 1.03. Okay, so that's for 1 year. If we just multiply them together, it will give us the amount after 1 year. To make it 2 years, we need to multiply by 1.03 again. So it's not just working out the interest, it's working out the interest and adding it on to the original amount. So if we do this calculation, so 4,600 times 1.03, that's what it would be worth after year 1. Multiplied by 1.03 again, gives us the value after year 2, which is 4,880.14, or £4,880 and 14 pence. Well, that is less than £5,000. So is Eden correct? No, because they said it would be more than 5,000. So they've worked that one out wrong. Question 4. Izumi takes a ring to a jeweller to check if it is made of pure gold. The density of pure gold is 19.3 grams per centimetre cubed. The ring has a mass of 5 grams and a volume of 0.35 centimetres cubed. The jeweller thinks the ring is made of pure gold. Is the jeweller correct? Show how you decide. Right, so this is a density question. Now, some people like to draw the triangle for density with mass and volume and density in there. But they always give it to us. When they give us the units, it's grams per centimetre cubed. So this is telling us that density equals grams over centimetres cubed. And grams are our mass, or weight, and centimetre cubed is a volume. So we can say that the density for this ring is the mass, which is 5 grams, divided by the volume, which is 0.35. And if we use our calculator, we get 14 point, let's do one decimal place, so 14.2, but this is more than 5, so round it up to 14.3 grams per centimetre cubed. Well, that is not equal to 19.3 grams per centimetre cubed. So is the joule correct? No, they're not. Question 5. Another 2-mark question. Jang knows it will take 2 decorators 12 days to decorate their home. Jang wants to have their home decorated in less than 6 days. If 5 decorators work at the same rate, will they decorate the home in less than 6 days? Show how you decide. So let's look at how much work there is in total. If you've got 2 decorators taking 12 days, that means each of them are working for 12 days. So in total, we've got 2 times 12, which means 24 days work. So if there was just one person doing it, it would take them 24 days. Now, if we've got 5 decorators doing it, well, then we can divide that 24 by 5. And if we do that, then it would take 4.8 days. Each of those 5 decorators work for the 4.8 days. And 4.8 days is less than 6 days. So, yes, they would be able to get it done. Question 6. This is for 3 marks. Round the value of pi. Use your rounded value to estimate the surface area of a sphere with a radius equal to 12 centimetres cm. Use SA equals 4 pi r squared, where pi equals 3.14159, SA equals surface area, and r equals radius. And this wants us to show our working. Okay, so first thing they said was round the value of pi. So 3.14, I'm going to round this, or say it's approximately equal to, let's do it whole number. So we'll look at the 3, the first digit after the decimal point is a 1, so we round down to just 3. Okay. So we're using this formula, so we're going to have 4. When you've got a number next to a symbol, it means you multiply them. So it's going to be 4 times 3, because that's what we're using for pi. And then we're going to multiply it by, well, r squared. R is the radius, and r squared means multiplied by itself. So it's going to be 12, our radius, multiplied by itself, which is 12 again. If you want to work out r squared first and then multiply them separately, that's fine. But they're all multiplications, so we can do it all just in one go. So we're going to have 4 times 3 times 12 times 12, which gives us 1,728. And that's going to be its surface area. So it's going to be in centimetres squared. So we just have to write that down here. Now, they haven't given us the units, so it's really important you put them in and that you make sure it's centimetres squared, not just centimetres. Otherwise you would lose a mark there. And question 7. This is for 3 marks. Milan has a target to run 10 kilometres each week. On Monday, Milan ran 1 1/3 kilometre. On Tuesday, Milan ran 2 1/5 kilometres. How much further does Milan have left to run to meet the target? give your answer as a mixed number. Okay, well, let's add the whole numbers together. So the 1 and 2 gives us 3 kilometres in total. We want to add the 1/3 and the 1/5. Now, often I'd say you can just use your calculator and convert these, but because they want the answer as a mixed number, we're going to have to keep it as a fraction. Now, when we're adding fractions, if the denominators are the same, it's fine. We can just add the numerators. When they're not, we say, well, does one of the denominators go into the other? In this case, they don't. So that means we're going to have to change both of the fractions. So we want a number that 3 and 5 both go into. So the easiest way is start with the biggest number, the 5, go up through the 5 times table and see if we find a number that 3 also goes into, is also a factor of. So we've got 5, well, 3 doesn't go into 5, 10, no, 3 won't go into 10, 3, 6, 9, no, 15, 3, 6, 9, 12, 15, yeah, that works. Or you could multiply the two numbers together. That would work too. So we're going to end up with two fractions, both of them having 15 as the denominator. Now, to get from 1/3 to 15, we multiplied it by 5. So we've got to do the same to the numerator. So what we're saying is 1/3 is equivalent to 5/15. Now, for the second fraction, to get from fifths to 15ths, we only needed to multiply that 5 by 3. So if we do the same to the top, 1 multiplied by 3 is 3. So 1/5 is equivalent to 3/15. Now, nice and straightforward, the denominators stay the same. And we've just got 5 plus 3, don't need a calculator for that one, to tell us it's 8/15. So in total, we added the whole numbers. He ran 3 and 8/15. We want to know what's left from 10 kilometres. So it's going to be 10 minus 3 and 8/15. Okay, so let's, how should we do this? Well, if we count back from 10, or if we take 3 off of 10, that leaves us with 7. So what we want is 7 minus 8/15. Okay, this is less than 1, so it's going to be 6 and something. Okay, where this is a mixed fraction. In a whole unit or a whole number, we would have 15/15. So if we want to take 8/15 away, we're going to be left with 15 minus 8 is 7/15. And we saw that we were already, it's going to be 6 something, so it's going to be 6 and 7/15. If you wanted to do it, you could turn them all into improper fractions. So you could say that 10 is the same as 10 times 15 over 15, or in other words, 150/15. And we could turn this into an improper fraction. So we would do 3 times 15, and then add on the 8. So that'd be 53/15, and work this out separately. So this is or, this is an alternative. And then if we continued from this, we'd have 150 minus 53, which gives us 97/15. And we would say, well, how many times does 15 go into 97? Well, it's 6 whole times, and 6/15 and 90, so it's going to be remainder 7, or 7/15. So I might have just completely overcomplicated that for you, but it's giving two alternative ways. The thing that would be easy mistake to make here would be that we take off the 3 to make it 7. We do this calculation and then we say that there's 7 and 7/15 left. But you've got to think, well, no, I'm taking more than 3 away from 10, so my answer's got to be less than 7. It can't be 7 and something. And we get down to 6 and 7/15. Question 8 for 3 marks. A sales manager wants to promote an employee. This table shows Joe and Sam's recent sales totals. So we've got, in week 1, Joe had sales of £1,050, Sam had sales of £1,400. In week 2, Joe had sales of £2,450, Sam had sales of £2,500. Week 3, Joe had sales of £3,000, Sam had sales of £2,900. And in week 4, Joe had sales of £3,000, Sam had sales of £2,590. The manager will promote the employee with the most consistent sales. Should the manager promote Joe or Sam? Okay, so if we're looking at consistency, or the amount of change in the numbers, we're going to need the range. And the range is calculated by taking the biggest number and subtracting the smallest. So if we look at Joe, what's the biggest number? Well, it's 3,000. He might have it twice, but that doesn't matter. It's still the biggest number. And the smallest is 1,050. So for Joe, we're going to do 3,000 minus 1,050. Oh, one too many zeros. 3,000 minus 1,050. Get £1,950. Now for Sam, the biggest number is going to be 2,900, and the smallest is 1,400. And that gives a range of £1,500. The manager will promote the employee with the most consistent sales. That's the smallest range, so it's going to be 1,500, which is Sam. So should the manager promote Joe or Sam? Sam. But it does say give a reason for your answer. So we can say Sam because they have the smallest range, and we can put 1,500 versus 1,950. Question 9 for 4 marks. A florist makes decorative wreaths. Okay, we've got a diagram here. Each wreath has a diameter of 25 centimetres, and the florist uses wire to make the frame of the wreaths. The florist has a 500 centimetre length of wire and needs to make 6 wreaths. Will the florist have enough wire? Show how you decide. Use pi equals 3.14. So the wire's going around the outside, so we're interested in the circumference. And the circumference of a circle, there's 2 ways you can work it out. It's either pi d or 2 pi r. So it depends if we've got the diameter or the radius. We've got the diameter, so we're going to go with this one. So we want pi. They've told us to use 3.14. Multiplied by the diameter, which is 25. So we've got 78.5 centimetres. Now they want to make 6 of them. So multiply it by 6, which gives us 471 centimetres. Now they've got 500 centimetres. Well, that is less than 500 centimetres. So will a florist have enough wire? Yes, they will. And we can pop that down in the answer box. Question 10. This is another 4-mark question. Kim buys a 4-pint bottle of milk to make milkshakes. Each glass of milkshake needs 0.35 litres of milk. How many full glasses of milkshake will Kim be able to make? Use 1 pint equals 0.568 litres. Okay, so we've got 4 pints. What we need to do is multiply the 4 by 0.568. So we're converting the 4 pints into litres. So let's have this down here. 4 times 0.568 gives us 2.272 litres. Each glass is 0.35 of a litre, so we want to know how many of those are going to fit in here. So we're going to do 2.272 divided by 0.35. Which gives us 6.49. We'll just do it to 2 decimal places. And they want full glasses. So we don't want the part of a glass. We're just going to go with 6 glasses. Question 11 for 4 marks again. Remy wants to make pumpkin soup. The recipe requires pumpkin, stock and carrots in the ratio 5 to 3 to 1. Remy has 1,200 grams of pumpkin. A 250 gram serving of soup is enough for 1 person. Will there be enough soup to serve 10 people? Show how you decide. So we've got a ratio question, so we're going to draw a ratio table. And we're going to need to have, let's extend this a bit. We're going to need something for our pumpkin, stock, carrots, and then we're going to have a total. We know the ratio is 5 pumpkin to 3 stock to 1 carrot. So if that's all we had, we'd have 5 parts pumpkin, 3 parts stock, 1 part carrot. Altogether, that would be 5 plus 3 is 8, plus 1 is 9. Now, Remy's got 1,200 grams of pumpkin. So not 5 grams, 1,200. So we want to work out how much soup we've got in total, because then we can work out whether it's enough for 10 people. So we've got to say, well, how do we get from 5 up to 1,200? So we do it in reverse. We say 1,200 divided by 5. Which gives us 240. So it's 240 times bigger. So we just want to multiply all of these values by 240. In fact, we don't actually need to do all of them. We could just go straight for the total. But what I want to do by doing this is just show you that if we do all of them, we can do a check. So 3 times would be 720. 1 times would just be 240. And if we do 9 times 240, we get 2,160. But actually, if we add these 3 together, 1,200 plus 720 plus 240, it should give us the same answer. And it does. So that's the total amount of soup that we've got. Is it enough for 10 people? Well, let's divide it by 10. Which gives us only 216 grams, which is less than 250. So, is it enough? No, it's not. Now, instead of working out how much soup you've got for 1 person, which is what I did here, you could have divided this total by 250 to see how many people you would be able to serve. Either way would be fine, because you would end up with an answer less than 10. So you'd still come to the same conclusion. Question 12, another 4-mark question. Lee has a tank in the shape of a cylinder. The tank is 50 centimetres high and has a radius equal to 40 centimetres. Lee has a hose that delivers water at a rate of 10,000 cubic centimetres per minute. How long will it take Lee to fill the tank? use pi equals 3.14. Well, let's start to think of this and visualize it a bit better. So we've got a cylinder. So cylinder is going to be something like this, like a can, and it's 50 centimeters high and has a radius of 40 centimeters. So that's quite a big radius compared to the height. Lee has a hose that delivers water. So we want to know how long it's going to take to fill it. So we want to know what the volume is first of all. Okay, so the volume of a cylinder is going to be equal to the area of the circle on the top multiplied by how high it is. So first thing we want to do is work out the area of the circle. And the area can be worked out using the formula pi r squared, where pi is 3.14 multiplied by the radius, which is 50. Oh no, sorry, the radius is 40. And it's squared, which means it's multiplied by itself. So 3.14 times 40 times 40 gives us 5,024 centimeters squared, because it's an area. Now to get the volume, we want to multiply that by the height, which is 50. Which gives us 251,200 centimeters cubed. That's our volume. Now, we want to know how long it's going to take to fill it. If it's filling up 10,000 cubic centimeters per minute, well then we want to divide this by 10,000, and that will tell us how many minutes it takes. I've still got it in my calculator, so I can just divide by 10,000, and we get 25.12 minutes. We don't have to convert that into how many seconds or anything like that. We can just leave it as 25.12 minutes. Question 13. This is a 5-mark question now. A school raised money for a new playground by having a charity auction. 35 people donated between £0 and £10. 18 people donated between £10 and £20. 26 people donated or gave between £20 and £30. And 7 people donated between £30 and £40. And there were 86 people altogether. The school wanted to exceed a mean donation, so an average donation, of 15.75 or £15.75p. Has the school achieved this? Show how you decide. So basically, they want us to work out the mean of this and see how it compares to £15.75. Right, now, when we've got ranges like this, it's hard to know exactly how much was donated, so what we have to do is work out our midpoints. So what that means is we assume that anyone that gave an amount in this range gave the amount right in the middle. So the way we work out the midpoint is we take the smallest number, the 0, add the biggest number, the 10, and then divide it by 2. So the midpoint would be £5 here. For the second one, we'd do the same thing. So we take the smallest, add the biggest, divide it by 2. So 15. Or you could just visually look and say, well, what number is going to be halfway between 20 and 30? Well, that would be 25. And halfway between 30 and 40, it's going to be 35. So that's our midpoint. So we don't need these anymore. Now, when we're working out the mean, we want the total, and then we divide it by the frequency. Now, the total in this case is going to be the total amount donated. And to work out the total, we have to do it for each of these separately. So what we're saying is 35 people donated £5. So that means they gave £175 in total. 18 people gave £15. That's £270 in total. 26 people donated £25. That's £650 in total. and 7 people donated £35. That's £245 in total. So if we add those all together, we get £1,340. We want to divide that by the frequency, which they've already told us is 86. And we get £15. We want money, so we're just going to take the first 2 decimal places. Well, we're going to round it, so 58. Next digit is a 1, so we would round down anyway. So we get £15.58. The school wanted to exceed a mean donation of £15.75. Well, that's actually less than £15.75. So has the school achieved this? Unfortunately, no. It's not far away, but they haven't exceeded it. It's definitely less. And finally, for this paper, we've got question 14. This is a 6-mark question. Jordan wants to replace the flooring in the hallway shown in this plan view. It's a plan view, so it's looking straight down onto it. So we've got measurement here, here, another one here. The cost of different types of flooring are shown below. So we've got maple, oak, walnut, pine and ash, and different prices for each of them. But they're all the cost per square metre. And it says we must buy a whole number of square metres. Jordan uses the modal cost to estimate how much it will cost to replace the flooring. How much does Jordan estimate it will cost? Okay, so mode or modal means the one that occurs the most. So let's have a look and see which occurs the most. Well, £55, we've only got it once. £65, only got it once. £87, only once. £45, we've got it twice. So the modal cost is £45. Now we need to work out the area, so we can then multiply that by the cost. Right, so we're going to do these, well, you can do this in 2 different ways, maybe even more than that, but I think 2 obvious ones. One is either we work out the rectangle and the triangle and add them together, or you could work it out as a trapezium and do it in one go. I'm actually going to do them separately. I'll do the rectangle and the triangle. So the area of the rectangle is the length times the width, which is going to be 4.4 times 2.67. Which is 11.748 metres squared. Now we're going to do the area of a triangle, which is calculated as half times the base times the height. So half, well, the base is 3.5 and the height is this bit, which is 2.67 metres. So half, so we can do it as 0.5 times 3.5 times 2.67. It's 4.6725 metres squared. Right, so let's get our total area. So it's going to be our 11.748 from the rectangle plus 4.6725 from the triangle, and that is going to give us 16.4205 metres squared. Now, if you recall, we must buy a whole number of square metres. So we can't buy 16.4, we're going to have to buy 17. Now, we're not rounding this, because if we bought 16, it wouldn't be enough. So we're having to go up to the next whole number. So we need 17 metres squared. And we're using the modal cost, which is £45. So it's going to be 17 times 45 which is £765. So we can write that in here. And that's the end of the paper. So I hope you found that helpful. Please like the video, subscribe to my channel, turn on your notifications so you get notified when I upload new videos, and look forward to seeing you again soon. Thank you.